Hello everyone, today I present my homework for Part 3. The topic is writing a leader degree language program to control piston and simulate it together with FluidSim. In this project, we use Siemens PLC and design a timer-based control system. The objective of this project is to use a Siemens PLC and program using little diagram language. The system must control a pneumatic piston and demonstrate the operation through FluidSim simulation. This project helps us understand sequential control, the timer logic in PLC programming. This slide shows the system architecture. The start button sends the start button sends an input signal to PLC. The PLC processes the logical and outputs the signal Y1 or Y2. This output controls the cylinder's valve, which driver the pneumatic cylinder. The timer is inside the PLC program to control automatic return. The main components include Siemens PLC controller, start and reset push button, cylinder valve, pneumatic cylinder, FluidSim software to simulation. This component from a complete electro pneumatic control system. The control sequence works as follows. When the start button is pressed, the piston extends. At the same time, the timer starts counting. When the preset time is reset, the piston recharges automatically. The reset button can start the system at any time for safety. This is a typical sequential control, which with timer function. In this project, we define input, output, and the timer address in the PLC target table. For example, I0.0 is the start button, I0.1 is the reset button, Q0.0 controls piston extent, Q0.1 controls piston recharge, T1 is the timer. Proper tag definition makes the program clear and organized. Row 1 controls the piston extension. When the start button presets, we use the set instruction to active Y1. Then set instruction keeps the output on even after the button is released. This creates a holding function. Row to control the timer. When Y1 is on, the timer starts counting. The timer ensures that the piston extends for a fixed duration. When the timer is done, the system automatically resets Y1 and sets Y2. This causes the piston to recharge automatically. This completes the automatic cycle. The reset button can reset both Y1 and Y2. This allows minimal stop at any time. It improves safe and reliability of the system. This style is so PLC program written in leader degree. On the right side is a tag table where we define the input and output addresses, such as the start button, stop button, and the piston output. On the left side is the leader logic. When the start button is preset, the piston output activity and held by a self-holding contact. When the stop button is preset, the carrier circuit is broken and the piston stops. This completes the base control logic. This slide shows the FluidSim simulation. When start presets, the piston extends. After timer finish, the piston restarts automatically. The simulation results matches the PLC logical design. Okay, this slide shows the real hardware demonstration. The physical PLC and the pneumatic system operate correctly according to the programming logic. This both simulation and hardware testing are successful. In conclusion, I successful design a leader degree program using Siemens PLC I implement timer-based sequential control. The student was very free using FluidSim and hardware demonstration. The project achieved all objectives. Okay, that's all of me. Thank you for watching.